Alright, so the deal is that, imagine for argument's sake, I wanted to y dx. Okay? Now there's a rule that it's called the chain rule that I can have anything in between. Ryan, pick a letter. That's a number. So can you pick a letter? Good man. So imagine there's an in-between formula L. So dy dx would be the same thing as dy dl by dl dx. See the way the sort of dl's cancel and they leave over dy dx. So if I had let's say, if I had the VDR, okay, I could make the VDR using the V and the R. And imagine so V is volume, R is a radius. But imagine that I could change that to the VDA by DAD, or just in between different derivatives you can use. Now, that currently makes no sense to you guys, but the only thing I want you to make sense is that you can separate the numerator and the denominator, and you can put in an in-between variable. So in the last case, what's the in-between one? The dA, isn't it? And in the first one, it's the dl. Alright guys. So, the area of a circle of radius r is given by the formula A equals pi r squared. Find the rate of change of the area of the circle with respect to the radius when the radius is 5 and the radius is 10. Okay, rate of change of the area of the circle with respect to the radius. They want me to find dA, dr. Now, the language is the tricky part. When you see the word rate, what does that usually mean? First derivative. When you see area, it means you're differentiating the area formula. What variable are you using? The radius. Everybody see how you take apart the language there? So what is the ADR? So it's pi times differentiate r squared, which is 2r, which is 2 pi r. And all you have to do is sub in 5 and you get 10 pi. And this one here, if you sub in 10, yeah, you get 20 pi. Now, what are the units is the interesting part. What's the units of area? Yeah. What's the units of radius? What's centimeters squared divided by centimeters? Yeah, it'd be just 10 pi centimeters. And this is 20 pi centimeters. Okay. You okay with that? Alright, let's move on to another one. Alright. Alright. The population of a new housing estate is 2 years after a certain date is given by this formula here. Happy days. Find the rate of change of the population after 3 years. What do you get here? Yeah, I'd multiply that in first. Actually, I haven't had to use my rate of change formula yet. I've simplified it down. Alright. Have to find the rate of change, don't I? So how'd you do that? The P, the T. The rate of change of population per unit time. So what do you think it is? It's going to be people per. Would everybody be happy for people per year? As the units? Yeah. Yeah. Good man, Carl. Come a long way. Now, let's multiply that. What you get? Everybody happy with 100 minus 50t? And then what happens next? 100 equals? 50t equals 2. Find the rate of change population. Oh, sorry. Whoa, sorry, I messed up. I found the maximum population is after 2 years. What does the question actually ask me for? Actually ask me for what's happening to the population after 3 years. If the maximum happened after 2 years, which was just proved accidentally, is your population on its way up or its way down? So we're expecting negative growth, are we? So what can we do here? What is it? Minus 50 people per year. So that estate is losing 50 people per year. So this is decreasing at a rate of 50 people per year. Alright lads, this is just a bit easier than I thought it was going to be. So I am going to go to 11 now. Let's go for the kill, okay? Let's have a look at this. A particle moves in a straight line. Oh, it's here. And it moves away from it. Its starting position. Feels like an applied maths question, to be honest. And what happens is it moves away from its position. Okay? And its distance or displacement from its original position is given to you by the following formula. Everybody cool with that? Now, if you look at this formula, just looking at, let's say you threw it into your table function, okay? So x cubed minus 5t squared plus 4t minus 5, okay? And you went from arguably 0 to 19, let's say. What happens at the very beginning? It turns into, what does minus 5 mean? Actually, it didn't go to the right, it went to the left. And then what happens when after 3 seconds when it's at plus 16? It changes mind and goes 16 the other side. Does that make sense? And then it keeps going until it reaches, I don't see no maximum here. Fair enough, still on its way up. Was there a maximum in that range? Let's see. I think the minimum was minus 5, or it might have been. And then, yeah, just keeps increasing. So it's pretty much always on its way up. Okay. So here's a rule for you. Okay, you ready for this? If the original formula is distance, the first derivative is velocity, and the second derivative is, take a guess, acceleration. That cool, you guys? All right. When its velocity is 0, what is the acceleration at this point? No bother. What I'm going to do is I'm going to differentiate this twice. So, get over it. And what we get is the STT, which is velocity, is 6t squared minus 10t plus 4. Second derivative, 12t minus 10. Okay. Now, we're going to see if this matches what we were looking at earlier. I'm going to have to solve this equal to 0, don't I? And it says points plural, which means 2 different answers, correct? Alright, so I'm going to solve this equal to 0. To find the 2 times where the velocity is 0. So, 12t, divide by 2. 3t squared minus 5t plus 2. And then 3t and t. And which one's 2? This is a minus b formula. Oh, sorry, it isn't. That one, yeah? So, t equals 1, or t equals 2/3. Okay, you guys? So they're the 2 times at which your velocity is 0. How do I find what the acceleration was? Solve it into the second derivative. And what you find out is that this one was 7 ms minus 2. Or if you put in 1, it's Oh, I left out 10. So it's -2. That means you're decelerating. And for the other one, it's 11. Oh, sorry, that's a 10, isn't it? Keep doing that. 2 ms. Ever caught that? And what happens when the acceleration is 0? That's 12t minus 10 equals 0. That'll be 12t equals 10. T equals 5/6. Okay with that? And then we have to sub that back into the velocity to get the velocity at that time, at that point. Alright guys, we'll have just run out of time here. So I did 3, 5, and 11. You guys are going to do 1, 2, 6, 8, 10, 12, 13.